Hello, just hopefully a quick video anyway, a quick video about inverse trig functions and not getting confused with the -1 meaning reciprocal or meaning inverse. Okay, so just got to be really careful. So when we write it on here, it's doubly confusing, because if I write sine squared x, what I mean is sine of x squared. And if I said sine of -2 x, then you might well think that what I meant was sine of x to the power of -2. But when I write it as sine to the -1 of x, I don't mean that. When we write sine to the -1 of x, then what we mean is the inverse sign. If sine of x, equals opposite over hypotenuse, then sine to the -1 of x equals sine to the -1 of O over h equals the x value, the angle. So what is going on here? Why is it sometimes the inverse and sometimes a power? And what about this, the reciprocal thing? Well, if you've seen my other videos, that's why for reciprocals we use cot, sec, and cosec instead of using reciprocals. So my example of sine to the -2 of x will never exist, because you wouldn't write that down. It would confuse matters. What do you exactly mean by that? So we don't use negative powers of x. If I wanted to say that, I'd say, okay, well, I want 1 over sine squared x. 1 over sine is cosec, so I'll write it as cosec squared of x. So these three words are used to mean I've done the reciprocal, rather than ever writing the reciprocal. I mean, you could put it in a bracket like this, that's fine, but you don't. We write cot, sec, and cosec for anything reciprocaled with sine, cos, and tan to avoid any confusion. But you can sort of doubly not have an issue if you use arc. So if you might have seen in textbooks, if not, then here it is for the first time. If you see arc sine or arc cos or arc tan, then this means the inverse function. So this is equivalent to saying sine to the -1 or cos to the -1 or tan to the -1. And the difference is hopefully I've made the point that the difference is quite crucial. I think this has become sort of standard, probably because calculators, it's shorter to write sine to the -1 on there rather than arc sine, especially when you need the button to do something else. But using this phrase, it's completely unambiguous that you mean the inverse function rather than a reciprocal function using these phrases. And the deeper into maths you get, the more you would use these to be absolutely clear about what you're doing. Where does this -1 come from? Well, I think it comes from function notation. So if you are familiar with function notation, you know we have a function of x like that, and the inverse function is f to the -1 of x. Now, I don't know which came first, actually. It might be that this started being used and then people started using it here. I've no idea. I wouldn't like to say confidently either way, but certainly that's the inverse function symbol, not the power of -1, even though it looks exactly the same. So you just got to be really, really careful not to mix the two up. Let's quickly go over to Desmos and have a look at what these things look like. So here we are on everyone's favourite graphical calculator, Desmos, and you can see that I have plotted out, well, I haven't, but I've got Desmos to plot out sine x, and if you have done functions, then you probably know that an inverse function is the mirror through the line y equals x. So let's put y equals x on the line here. But it still has to be a function. So if I now reveal what arc sine of x is as a function, then you'll see, oh, there we are, that it does indeed look like the mirror image, but we only get this little bit of it. It's undefined anymore. You'd think, well, if it's the mirror image, well, then shouldn't it carry on oscillating up and down the page? But it can't, because if it did, you'd have a one-to-many relationship. If this carried on going, one x value could produce several y values, and that's not allowed in functions. Is you're not allowed that relationship where one value produces lots of different answers. You can have a situation where different answers all produce the same y value. That's a many-to-one relationship where many x values produce one y value. That's fine, but you're not allowed to do it. If I wrote it in the other way and defined it the other way, x equals sine of y, well, then I get the whole thing, but that's because I'm defining I'm kind of using the x as the y-axis and the y as the, I'm doing it the other way around, so that is defined because this is x as a function of y. So that's allowed because one value of y only produces one value of x. It can't produce multiples in the opposite way. But if we just delete that one, don't want to confuse things. So it's just this mirror image. So it's this shape here, and I say it's only defined in this range. It can't go any further out sideways because you know, if it was going to do anything, it would carry on going up and down. But like I've said, we can't have that go any further. Let's have a look at the other ones. So if we get rid of arcsine and put cos on, then the mirror image of this is going to be arc cos. So that's an interesting little picture we get drawn there. So it's the same thing really as arcsine, but it's flipped over and moved upwards. It's they share the point here, and I think that's because that must be, oh no, they don't share a point there. It's very close. They do cross over at a point, but not where I was thinking. That must just be where, where the value where the two cross over. If we look at sine and cos, no, it's not even where they cross over, but there is a bit of a symmetry going on with all the four lines. But anyway, let me stop rambling on about that. Yes, so it kind of looks very similar. Well, that makes sense because it's the same shape, just shifted along. So when it gets reflected into the same shape. But we've just cut off different limits because it's been shifted along. It sort of projects in different places. And if we look at what arctan is, well, then this does go sort of infinitely wide. And if I put, let's get rid of the other ones, and so we can see what it looks like. So here's tan. What you can see is we've just taken this one curve here, and reflected it. And again, we've got to do that because if we reflected all of them, then we would get the one-to-many relationship, which we're not allowed. But when we do reflect that, this coming up to infinity here is going to go over to infinity there, and down here, it just changes it from up and down to left and right, just like before. But with sine and arcsine, of course, because this is bound, it's not going up to infinity, then this is bound left and right, and we're just cutting off the repetitions top and bottom. I'm not entirely sure how important it is for you to know these shapes of these graphs. They are in the textbook, but I think if you know how the inverse functions are graphically produced, then you can probably work them out if you needed to sketch them. If you understand that reflection in y equals x, then you can probably work them out rather than having to remember them. So not such a quick video in the end, I'm sorry about that, but I got sidetracked onto looking at the shapes of the graphs and etc, etc. But hopefully you have a clear understanding that the inverse of functions, arcsine, arccos and arctan, and why we use that wording instead of the -1, and the reciprocal functions, sec, cosec and cot, and why we use those words rather than these powers, so that we don't get confused with whether we are doing a power, a reciprocal, or an inverse function. If you have any questions, then they can go down in the comments below. Otherwise, ta-ra for now.